Okay, so we're going to continue with this week's lesson, and we're going to discuss the concept of single case design, quasi-experimental designs, as well as developmental research. So let me go into full screen. The general learning objectives is to describe what a single case experimental design is, explain reasons why one would use that kind of design. Then we'll go into the concept of program evaluation and the 5 aspects of that. Then we'll talk about various research methods that approach valid or pre-experimental designs and then experimental designs, one of which is a one-group post-test only design. Then we'll talk about some of the problems with a one-group post-test, and then we'll look at a one-group pre-test post-test, then non-equivalent groups design, and then we'll go through. All right. Then we'll talk about developmental research, such as cross-sectional, longitudinal, and sequential research, and we'll address the issue of cohort effects. So let's start with the concept of a single case, or you might hear it referred to as a single subject design. So a single case or a single subject design is a design in which you're using a sample size of 1, you're using a single participant, and you want to see if your intervention worked. So you might see this model written in the form as AB. So A being at baseline, B being treatment. So we want to measure a person's behavior before intervention, and we want to measure a person's behavior after intervention. So this is what we call A during baseline and B during treatment or after treatment is introduced. But here's the problem. It's possible that other things are happening in the person's environment that could have simultaneously caused this effect. And because we're not sure if it's a treatment or some environmental factor, we have to go a little bit further. So in order to determine whether or not the treatment was really the cause of this outcome in a single subject design, you might want to consider what's called a reversal design. And a reversal design, some people refer to as a withdrawal design. So after you introduce the treatment at the second point, you withdraw it again. Now, if the treatment was truly the cause of the change of behavior, when you remove the treatment, the behavior should return back to baseline or pre-treatment levels. If the behavior does not go back to pre-treatment levels, we have to consider several things or several interpretations, one of which is maybe it wasn't our intervention that caused this outcome. Now, some things cannot be reversed or removed. So the only time you can use a reversal design is when it's possible to reverse the intervention. So again, we still might have concerns about some kind of event outside of the manipulation that caused this outcome. So what you would see is you might see something called an AB design, which is a second introduction of the treatment. So the initial AB baseline to treatment, we had concerns about history. We still have concerns with an ABA design because you're reverting back to baseline, but we're still concerned about environmental factors. So we'll talk about an ABAB design and how that addresses some of this. Another consideration with a reversal design is sometimes it's impossible to withdraw a treatment, especially if it's beneficial. So there are times when the reversal design can't be used for ethical reasons. But here would be an example of an ABA design. Again, A standing for baseline, B was when you introduced a treatment, and then going back to baseline. So let's say you are working with a person, you want to see how many correct problems they got on their homework before intervention. Then you got some kind of tutor or some intervention service, and then the number of homework problems were correct. And then you withdraw that tutoring service. And then you want to see if the tutoring service was effective. We would anticipate the number of correct problems to drop off again in successive days. But again, we have multiple reversal designs, and this is the preferred method, is the idea of an ABAB design at a minimum. So you've introduced the treatment, you withdrew the treatment, and then you reintroduce the treatment. If it goes back up to treatment levels, again, we can cast less and less doubt about the validity of this outcome. Now, you might see an AB design. All that is that there's a third reversal and a third introduction of treatment. So what's the benefit of having multiple reversals? As I said, you have less question about the outcomes, and then you have more certainty about the effectiveness of the treatment. So if we were to look at treatment 1, treatment 2, treatment 3 using this multiple reversal design, let's look at treatment 1. Well, in a scenario of treatment 1, we would say this treatment is pretty effective, right? Because before treatment, you had these levels, then you introduce a treatment and there was an improvement in behavior. Then you remove the treatment, then it regressed, reintroduced the treatment, and the behavior increased again, and then you remove it again and it dropped off again. So treatment 1, we can say with certainty that the treatment was fairly effective. Treatment 2, we can say with fair certainty that the treatment was ineffective, right? Because no matter when we introduced, removed, reintroduced, removed, the levels for treatment 2 just stayed at baseline levels. So we're not going to say that was an effective treatment. Now, treatment 3 is, it's complicated. It's possible that treatment 3 was effective. It's possible that treatment 3 was not effective. Here's the argument for treatment 3 being effective. In this scenario, this was the kind of intervention or treatment you could not undo. So if you're given psychotherapy services, you can't take away the services you've already given. So it's possible that the person grew and remained at that heightened awareness state. But it's also, here's the case against treatment 3 being effective. It's also possible that some outside factor altered the behavior significantly. And that's why when you try and return to baseline, it didn't. So 1, we know is effective. 2, we know is ineffective. 3, maybe it's effective depending on what's going on. So what do you do? Well, what do you do when you might not be able to do a reversal design? You might want to consider a multiple baseline design. That is to say, you have multiple participants, and I'll give you examples other than participants, but the common scenarios, you have multiple participants. The first participant is introduced to the treatment while the other participants are not. So in the graphic on the right, you'll notice that on the x-axis is time. So person A received the treatment before person B and person C. Now, if you see that the same treatment modifies the behavior across participants consistently, then we could say that that treatment was effective as well. So you go across several participants or subjects across time. That's one scenario. A second scenario is to see if you can generalize a behavior within a single person with the same intervention. So you introduce the same intervention for socialization. Let's say you're working with a person on the autism spectrum. Introduce for socialization while still not introducing for grooming and reading. Then you introduce it for socialization and grooming. Then you introduce it for socialization, grooming, and behavior. And then if this discrete trials works across behavior, then we could say it was effective. And then across situation, again, it's generalizing from one scenario to another. Those of us who have kids, we might hear teachers say, "Oh, your kid is so amazing," when you see a different set of behaviors at home, or vice versa. You could have a kid that's well behaved at home and misbehaves in school. So if you're trying to get the kid to behave consistently across situations, then you might introduce treatment in one area, one situation, then add a second and third later. So again, another scenario, right, showing you multiple baseline. So if we wanted to see if the smoking cessation program was effective, this is across participants. S1 stands for subject one or participant one. Before introducing, I don't know, let's say some uh, chewing gum, right? Chewing gum, so nicotine gum in replacement of cigarettes. Person one was smoking about 300 cigarettes, and then they dropped and eventually stopped because of the gum. Mind you, person two, still in where the first dashed line is, hasn't received the chewing gum. But once we give them the chewing gum, their behavior drops, their cigarette smoking drops. And the same thing with person three. At a certain point, we could say that chewing nicotine gum might be a successful replacement for cigarette smoking. So that would be across participants. Now, when you use single subject design or single participant designs, it's very, very important that you replicate your findings to make sure that these findings are not an anomaly or some kind of fluke. So you might do experiment one, experiment two, experiment three, where you are replicating the outcome to increase confidence in the outcome or generalizability of the results. So typically, though, each participant is its own experiment. And then we sometimes write a general summary afterwards to explain the patterns. So that's single subject design and various ways. For the purpose of studying, I want you to know the concept of baseline, what baseline is, what treatment is, what reversal designs are, what multiple reversal designs are, and why you would do it, and then when you would have multiple baselines. The next thing we look at is program evaluation. Let's say you wanted to create an intervention. You have to evaluate that program on multiple levels to deem it worthy. So there are 5 elements of program evaluation, and each one leads to the next, and all must be there for you to recommend a program continue. The first thing you need to do is a needs assessment. Is there really a problem? So let's say our program that we were talking about was drug abuse resistance education, or the DARE program. Is there actually a drug abuse problem among teenagers in this community? If you find that the answer is yes, then you could start moving to the next level of creating a program. But if you don't find a need, don't create a solution to a problem that doesn't exist. All right. So where would you demonstrate, or how would you demonstrate that there might be a need for a program? Well, you could do survey research, you could do personal interviews, you could go into public records, whether it be health data, criminal records, et cetera, to build a case for the need for the program. All right. Once you have a need for a program, then you're going to create a program. And phase two, pardon me, then once you have a need for the program to address the problem, you create a program. The phase two is to do what's called a program assessment. You want to look at that program and ask, does this theoretically look sound? Does this program look like it could address the problems that we now detected? So then the answer is yes or no. If the answer is no, then you have to refine the program. If the answer is yes, then you move it to the next level, which is a process evaluation. You introduce the treatment, and then you want to see if the treatment is being implemented consistently. Is it actually reaching the target audience? So is the process being done effectively? Okay, so if everyone is trained effectively in, I don't know, DARE programming, and then they go into schools to do the DARE program, now we have to see, did the DARE program decrease the likelihood of drug abuse? So this is what we call outcomes evaluation. So this is phase 4 of a program evaluation. Did it result in the target that we wanted? So we saw a problem, we created a program, it looked like it could address the problem. We trained people to implement the program. Now, did the program actually work? And that's called an outcomes evaluation. If the answer is yes, you move it to the final phase, which is called an efficiency assessment, which in the corporate world or the business world or the government world, that this is probably what they're most concerned with, which is, is it worth it? Does the financial cost of the program meet the benefits, or are the benefits better than the financial cost? So in the event that it has the desired outcome of reducing drug abuse, does it reduce it enough that the program's worth it? And that's an efficiency assessment. And that's your 5 aspects of program evaluation. Notice how it is in a sequence. All 5 must be met in order for you to say you have a meaningful program. So the next aspect of this lecture is what we call a quasi-experimental design. Now, quasi-experimental design is almost experimental, meaning it has some of the properties of an experimental design, but not all of them, right? So there are 6 types of quasi-experimental designs. The first 3 are referred to as pre-experimental designs because they have enough challenges or flaws or problems that we're not convinced that the outcomes could be interpreted meaningfully. So we'll go through all 6 of them, but 4, 5, and 6 are where we should be. So the first quasi-experimental design is what's called a one-group post-test only design. Now, you already know what a post-test only design is. We learned about that in lectures, I want to say 8 and or 10. But a post-test means that you introduce the independent variable and then measure post-test. You measure the dependent variable once, and that is after post-test, measured after you introduce the independent variable. Now, what's the problem with a one-group design is that you don't have a comparison group. So in this case, all groups receive the intervention, and you have a measurement on the dependent variable. So that's not really enough of a design to say that it's experimental hence its pre-experimental moniker. It also lacks random assignment, right? So that's it. Two issues is it doesn't have a comparison group, doesn't have random assignment, and then we might have a little more confidence if it had a pretest, and we'll talk about that too. But nevertheless, this one group post-test only design is not sufficient to draw any meaningful conclusion. Then we have the one group pre-test post-test design. So now we're pre-test, we're measuring the dependent variable before and after pre-test, post-test, introducing the independent variable. So let's say we wanted to see if our smoking cessation program was effective. We might want to see, well, how much did you smoke before the program and how much did you smoke after the program? The problem is that because we still don't have a comparison group, there's no way to be certain that the program was what caused this change or whether something else happened. So there's a whole host of problems that could occur, environmental factors that could have led to this outcome other than a program. So without a comparison group, we can't make meaningful interpretations. So as I said, there are a lot of problems. So one issue is history. And those are environmental factors that happen and coincide with the pre-test and the post-test that might have shifted the post-test behavior. Maturation is another one. So a person might have grown in a meaningful way between the pre-test and the post-test that could have resulted in this outcome. There could be a problem with testing. And remember how we talked about a pre-test effect? Well, this is what testing is. It's possible that the pre-test tipped off what you were looking for. So when you do the post-test, it changes the responses on the post-test. Instrument decay, it's possible how you measure the dependent variable shifted between the pre-test and the post-test. And regression towards the mean, extreme scores have a natural tendency to move towards the center of the distribution with or without intervention. So regress means go backwards towards the mean. So if you're extremely high on a measure or extremely low on a measure, you're going to move towards the middle naturally. So if a person was smoking a lot, and it's possible that they smoked so much that anything would have brought them towards the middle, or in this case, reduce their smoking. So we went through these threats to the design. So now let's talk about a non-equivalent control group. This is 3, right? So, and this is what we talked about in lecture 8. If you don't have randomization, it's possible to have selection differences. So here you now have 2 groups, one treatment group and one control group, but it's called non-equivalent control group because we're not sure if people started out differently than one another, and whether it's your training program or pre-existing differences. So that's why it's so important to do random assignment, right? That's why it's so important to have that element so that we can say we've neutralized these individual differences. And here's the notation for the first 3. Again, one shot, one group, pre-test, post-test. Again, one shot case study was the post-test only. Static group comparison, this is the non-equivalent control group. Different books will refer to things differently. So this is a screenshot that I took out of another book to show you scientific notation. So now let's talk about a non-equivalent control group pre-test, post-test design. Here's the deal. You still don't have random assignment, but it's better than not doing a pretest, because if there are pre-existing differences, you're going to catch it with your pretest, right? So you're going to measure the dependent variable for both groups even before group A gets the treatment and group B serves as a control. So Can you eliminate those selection differences? The answer is no, but you can detect them if they existed beforehand. So that is tremendous. And this is why if you cannot manipulate a factor, we use this at a bare minimum, a non-equivalent control group, pre-test, post-test design. All right. Then we have time-related design. So we have an interrupted series design. So this is sort of like following people through time. An interrupted time series design is one group followed through time, right? So in the interrupted time series, that's your top graph, and they're measuring the number of automobile fatalities before introducing a red light or a stop sign. So if there are a number of automobile fatalities, they say, okay, well, this particular road needs a light. They add a light, and then fatalities go down, right? So here's the deal. Was it the red light or was it something else? Well, we don't know, right? Because in this top scenario, 1955, it was extremely high, right? So when we introduce this intervention, maybe you have regression towards the mean. So we don't know. But one way to address this, if you're following people through time, is what's called a control series design. And that's where you have a control group where you don't put a stop sign. So again, instead of number of fatalities, it's fatality rate. You take two groups that had similar fatality rates to begin with, and then one group gets the treatment, and then the other group does not. And in this case, the solid bolded line is the group that received the treatment, and the dashed line is the control group. And in that scenario, what we see is adding the stop sign was effective because you have a marked drop off relative to the group that fatality rate stayed plateaued relatively flat. So that is more meaningful in drawing conclusions through time. And here's how you would use scientific notation for the other three designs. So a pre-test, post-test, non-equivalent design, a time series design. Notice you're measuring the dependent variable multiple times before and multiple times after the intervention. And then the non-equivalent before-after design, you're measuring a treatment group and a control group multiple times before and after the intervention. So that's when we talk about quasi-experimental designs. You'll also, if you take developmental psychology, be introduced to other developmental research designs, things like the cross-sectional method, the longitudinal method, and the sequential method, right? So listen to how I say it. Cross-sectional is you have multiple groups at one point in time. Longitudinal is one group measured at multiple points in time, and sequential design is multiple groups at multiple points in time. All right, so let's go there. So the first one we're going to talk about is longitudinal design. This is one group that is studied across multiple periods of time. So let's say you were interested in whether or not a personality trait is relatively stable. You might take the same group of people and test them over and over and over through time to see if that character trait remains the same or whether it changes across development. So it allows, the benefit of longitudinal designs is it allows you to study the behavior before and early in development and later in development across time. The problem with longitudinal research is that if you were to study someone, you might study them for 10, 20 years before you have a conclusion. what are some problems with longitudinal research? One is that by the time you publish, your findings could have already been discovered by someone else. So that would make your findings absolute. It's also possible because you had one group that the group you selected to begin with was biased in one way over another, and you didn't get a full picture in your group. You also have an issue with what's called mortality, which is your dropout factor. I think we talked about that as well. So if people drop out of your study and you only have one group, you won't know whether they're systematically dropping out based on your intervention or something else. Practice effect, repeatedly testing people might tip them off or increase their testing ability. And then something called cohort effects. Now, a cohort effect is we know that people born into certain time periods have similar life experiences, life events, and that could alter how they respond. And knowing this, we are concerned that maybe it is a zeitgeist factor or a timepiece. And if we had a group from a different era or time, maybe they would respond differently. So we always have to worry about cohort effects. So maybe people who are Gen Zs might behave differently than Gen Y or Gen X people, so to speak. So one way to address this is to do a cross-sectional design. And in this case, you have multiple groups being measured at one point of time. So what's cool about this design is that you eliminate the fact or the likelihood of the data becoming obsolete. You can assess mortality factors, selective attrition, practice effects, and all of these things. Now, and it's cheaper and more efficient. So, but you still have some problems, right? So even though this design is pretty good, you still could have cohort effects, right? That's important to note. And you can't track people through time to see developmental changes, right? So group differences may be maybe there are differences in different age groups on this personality factor, but we're not sure at what point in development that change happened. Longitudinal designs allow us to track earlier relative to later points in history. And because you're compared relative to yourself, you get that meaningful difference. So maybe there are group differences and maybe there are cohort effects, which we've talked about. So the third and final design that we consider is something called a sequential design. You might hear it referred to as a cross-sequential or a cohort sequential design as well, because it allows for multiple groups at multiple points in time. Now, what's the nice thing about this? Well, it gives you all the benefits of a longitudinal design because you're following a given group through time. It gives you the benefits of a cross-sectional design because you have multiple groups and you can compare them at a certain time or year of testing. It also allows you to determine whether there are cohort effects, and it allows you to determine when development takes place. The biggest challenge with even a sequential design is that it still can't eliminate the cohort effect. It has all of the problems of the longitudinal design too, but you can identify them if they're present. So it doesn't get rid of the problems, it just allows you to detect them better. All right, and here's the various research designs by comparison. Sequential design, cross-sectional design is multiple groups, right? Group 1, 2, 3, being tested at time one point in time. Whereas a longitudinal design is group one group being tested at multiple points in time. In this scenario, is time 1, time 2, time 3. And then a sequential design is multiple groups, multiple testing points. And that is our lecture in a nutshell. So let's stop that, and I'm going to stop recording. and we're